by accident that when a magnetic needle is above a current carrying conductor, then the magnetic needle deviates. So in this picture, you can see that you have a couple of cells, and then a current is flowing through a conductor, and then underneath it is a needle. So the moment the current starts to flow through the conductor, this magnetic needle deviates or starts to rotate. So a few important facts about this is that when an electric current flows through a conductor, it causes a magnetic field around the conductor. So think carefully about it, what we've just seen. When an electric current flows through a conductor, it causes a magnetic field around the conductor. And now we can use this to make a temporary magnet. Now, what does temporary mean? It means that you can switch the magnet on and off. You can decide when you want it to be a magnet or when you want it to be off. So when the current is flowing, while the current flows, it is then magnetic. But when the current does not flow, it is then not magnetic. So you can switch it on and off. And this is called an electromagnet. And if you look at the word, electro refers to electric current, and then it also refers to the electric current can create a magnet. So let's look at the description of an electromagnet. An electromagnet is a temporary magnet made by winding wire around an iron core. So if you look at the next slide, we can build an electromagnet. So what do we need to build an electromagnet? You need a few electric cells or torch batteries, a piece of conducting wire, and an iron nail. And then how to construct an electromagnet, what should you do? The first step is that you have to wrap the wire around the iron nail to form a coil, as you can see in this picture. So you wrap the wire around the nail to form a coil. And then if your coil is nice and tight, you can connect the one end of your conducting wire to the one terminal of a cell, and you can connect the other end of the conductor to the other terminal of the cell. So here I've made for you a short video to indicate or to show you how an electromagnet can actually works. So just watch the short video, just 2 minutes, and then it's going to give you a lot of information about an electromagnet. The current, or I open the switch, and you can see the iron nail loses its magnetism again because there's no current flowing and it's no longer magnetic. Now I have replaced my electromagnet. The one that I used before only had a few turns or coils around the iron nail. Now this new one has many more coils around or turns around the iron nail. Now let's see what the effect is. I still only have 2 cells in series, but many more turns of wires in the coil, and you can see the electromagnet is a bit stronger. It picks up more of the pins. For this last part of the demonstration, I'm still using my electromagnet with many turns of wire around the iron core. I have the same number of pins, but now I have connected 2 extra cells in series, so I have a total of 4 cells in series now. Let's see how that affects the strength of this electromagnet, how many pins we can pick up with this electromagnet now. You can see it's much stronger than the one with less turns, and it's now stronger because we have 4 cells in series. If we take it to the side, and if I open the switch and the iron core loses its magnetism, then we can count the number of pins that we actually picked up with this electromagnet. Let's count them. 1, 2, 3. There's 4, 5, 6, 7, 8, 9, 10, 11, 12. We could pick up 12 pins with this electromagnet. What made the electromagnet stronger? We had more turns of wire around the iron nail, so there were more turns of wire in the coil, and we had more cells in series, so that makes an electromagnet stronger. So if we continue then with the slides, let's just recap on what did we use now. We used different components. The one component of this electromagnet was a battery or cells, electric cells. And what is the purpose of the battery? It is to provide energy for the current to flow, because if there's no current, there's no magnetic field. And then secondly, we had a coil of wire that was turned around the iron nail. And what is the purpose of the coil of wire? That is where the current is going to flow through, so that a magnetic field is created. And then lastly, we had an iron core or an iron nail. So what is the function of this iron nail? It is to concentrate the magnetic field around the coil to make the magnetic field stronger, so that our electromagnet is more effective. Now, in the video, you saw that I discussed, or I demonstrated 2 ways in which you can make your electromagnet stronger. So the first one was to add more cells in series. When you add more cells in series, I'm sure you know by now, then you have a stronger electric current. So at first, we used only 2 cells. And then in the end, we used more than 2. We used 3 or 4 cells. So if you add more cells in series to make the electric current stronger, your electromagnet also becomes stronger. And then a second way to improve the strength of your electromagnet is to increase the number of wire turns in the coil. So what does the word increase mean? It means make more. If you make the number of wire turns in your coil more, the electromagnet becomes stronger. So in the first electromagnet, I had an electromagnet with only a few wire turns. So the electromagnet was weaker, but then afterwards I used an electromagnet with many more wire turns in the coil, and therefore my electromagnet became stronger. So why is it important that we know about electromagnets? Where do we use electromagnets in everyday life? I have a few examples here. Firstly, a house doorbell. When you press the switch and you close the current, the circuit, then the current starts to flow through the electromagnet in the doorbell. And when the electromagnet attracts this metal pin, this little ball will hit the dome of the electric doorbell, and then it will start to ring. So a house doorbell works with an electromagnet. And then even in loudspeakers, I'm sure you have seen this, or similar loudspeakers. In the casing at the back of the loudspeaker, there's also an electromagnet, and the electromagnet then also becomes magnetic and loses its magnetism on and off through the electric current that flows through it, and this causes the diaphragm of the loudspeaker to move up and down to create a sound. A third example of where we use electromagnets is in scrapyards, where we want to separate metal objects from other objects. So you have a big crane like this, and there is your electric conductors that will take the current to this big metal disc. The moment the current starts to flow through that big metal disc, it becomes magnetic, and then it will attract pieces of iron, and it will separate it from the other rubbish on the dump, so to transfer it to another place so that it can be recycled and reused. Another example where we will find electromagnets is in any device that we have in our homes that uses an electric motor. Now, a fan is one example, a hairdryer, a heater fan, a drill that you use to drill holes in a wall. All of those things will contain electric motors, and inside the electric motor you will find electromagnets. And then very common these days is magnetic locks on safety gates and safety doors. The pieces of metal become magnetic when the current flows through the electromagnets, and then they cling together. So while the current is flowing, those magnetic locks stick together, and then the gate is locked. So to open it, you have to break the current. So that is my story about electromagnets. So again, to see what you've learned today, you can complete the quiz in this link. And I'm also going to share with you the QR code for the electromagnet quiz. And good luck, and thank you for listening today.